Alright, we're going to be picking up where we left off in the last video with the phase and the magnitude, and we're going to be plotting it using Matlab, but in this case my Camtasia is not working on my desktop that has the Matlab, so I'm going to be doing it on my Surface Pro and just showing you the code. Alright, well here we have our x-axis that's going to be used in our magnitude and phase plot, and it's just our omega, and we're going to do it to negative 2 pi, to 2 pi, and we're just at 1,000 points because we want to make sure it's nice and smooth. And we chose negative 2 pi to 2 pi. So as you can see in this graph right here, so we can get these, we can actually get the peaks, the where the band stops at, and clearly see it's a band stop instead of, because if we did it to pi, we wouldn't have this up right here on either side. And of course we could do it to a higher pi, do like negative 4 pi, negative 3 pi to 3 pi or whatever, and that's what we've done below just to show you that it's doable. That's our phase plot with the negative 2 pi to 2 pi, and this is the magnitude plot with the negative 4 pi to 4 pi, and this is the phase plot to negative 4 pi to 4 pi. So you can elongate the lens space if you want to, and it's still going to show you the general same characteristics. Alright, so now we enter our equation of x omega, which I just called x here, which is equal to 1 plus exponential to the raised to the negative j times omega. Next, we're going to be plotting them here and here, and you might be thinking, well, where are we getting the magnitude and the phase from? We're using the function absolute to get the magnitude, and we're using the function angle to get the phase angle of the x omega function for all the omega. And once again, you saw the graphs they produce. Alright, I'm going to go over here real quick so I can fill it in, because I didn't add the x and y axis labels in before I screenshotted. So our x-axis is labeled by omega, which is radians a second, and then we have our y-axis being our magnitude. So what does this look like? You gotta look at it and you have to be able to tell. You need to know if it's a filter, if it's an amplifier, or whatever. And in our case, this is the filter we're dealing with. So what type of filter is this? Well, as you can clearly see, it's going to be a band stop, since this is the origin right there. And it's coming back up to past the high, some of the high signals, some of the low signals, and it's going to keep repeating as you saw with the negative 4 to 4 pi. So it's a multiple band stop. So that helps us. That's why the magnitude is so important, is it lets you know what type of device you're dealing with. And like such an amplifier, you might not be having no stops, like the band stops like this, and it might be something more of just a wave showing you the gain throughout the system. So it's even helpful with things like amplifiers and other systems. Alright, now let's move on to the phase. The phase, as many of you might know from classes like Circuits 2 and Signals 1 with Belkacemi. Good luck if you had him. But the phase has to do with the delay of the system. So if our signal goes through the system, we're going to get a phase plot. And this phase plot right here is going to tell us the delay the signal sees after it has went through the system. This is important to know for such things as control analysis and other things along the lines of analyzing a system in the professional field. Also, from the phase, you can also find the group delay of the system. They're both similar, so it's not a huge difference, but the overall importance of the phase is finding the delay. And this is why the frequency response x omega is so important. Is because from x omega, which is equal to the frequency response of our system, we can find all this useful characteristics of the device / system. And I hope you found this video helpful to explain why the magnitude and phase is so important.